Greetings to all. In this lecture, we will discuss the stator winding design with an example on fractional slot windings. Here we will discuss the coil pitch and how to select the number of coils, how to make the connections using stubbing and arrow check representation, and also complete winding design. We can see here fractional slot winding and 18 slot 3 phase 4 pole winding as an example, and 18 slot stator core we can see here, and slot numbers from 1 to 18 have represented, and the slots per pole per phase small q is equals to capital Q divided by number of phases into number of poles, that will give 3 by 2, because it is a fraction q value is equals to 3 by 2. That is the reason we are calling this type of winding is fractional slot winding. Next, pole pitch is equals to 18 by 4, 18 slots divided by 4 poles, it will give 4.5, and 9 by 2, 9 by 2 also a fraction, and we have to distribute 4.5 slots under each and every pole. We can see here a different color representation. This is pole 1, pole 2, pole 3 and pole 4. Under each pole 4.5 slots are accommodated. So, in order to split or in order to share the slot into two parts, we have to design the double layer winding for that thing, and coil pitch is equals to 4.5 with respect to the pole pitch. If we want to design a full pitch winding, coil pitch also should be 4.5, which is not possible. We can select either 4 or 5. So, if we will select the coil pitch is equals to 4 slots, then it will be short pitch winding, and if we will select coil pitch is equals to 5, then that type of winding is called over pitch winding. So, for this example I have considered coil pitch is equals to 4 slots, and slots per pole per phase is a fraction. So, in order to make the winding, double layer winding is required, and the coil sides or layers per slot will be 2, and the number of coils with respect to the double layer winding is 18, and coils per phase is equals to 6, and total number of coils to make the winding is 18. The winding design procedure is same as the single layer winding and double layer winding. First we have to define the number of turns with respect to the Faraday's law of voltage equation, then conductor gauge selection with respect to the current for a given voltage and for a given power rating, and we have to make the 18 coils with respect to the given example, like 18 slot 3 phase winding double layer, right. So, 18 coils we have to make, and coil pitch is 4, and after that we have to place the coils in respective slots, and before placing the coils we have to place the slot liners. We can see in this image the white color one, to insulate the conductors from the stator core, and coil side separators between the two coil sides. Let us say here these are the two coil sides, in between we have to place the coil side separator, that is insulating papers we have to place, and winding connections with respect to stubbing and arrow check approach, and verification of the developed winding with respect to the right hand thumb rule for magnetic pole formation, and placing the insulating papers and sticks to close the slot, and end winding threading and varnishing to make the rigid and tight with respect to the winding, and validation of complete machine at the rated operating conditions. Now, first we have to place the coils one by one. So, with respect to the coil 1, this is one coil side, this is second coil side with respect to the coil 1, like this 18 coils we have. So, first coil side we have to place in slot 1, and next coil side we have to place in slot 5. Since it is a double layer winding, we have to place one coil side at the top side, other coil side at the bottom side. As per the coil pitch, 1 plus 4 is equals to 5. So, one coil side we have to place at slot number 1, other coil side we have to place at slot number 5. Next, slot number 2, we have to place the coil side in slot number 2 and slot number 6. This is second coil. We cannot place one more coil in the slot 1 because 1.5 slots we have to distribute for each and every phase, right. So, if we will place one more coil here, the C phase conductors we cannot accommodate it. So, each coil phase spread will be 1.5 slots only. So, one coil sides which are placed at the bottom side of the slot number 1 will go backward manner. Next, slot number 6, top side we will place the coil and the next end will go to the slot number 10. We can see the next coil related to the A phase. Similarly, the fourth coil related to the A phase, which is placed in slot number 10 and slot number 14. 10 plus 4 is equals to 14. So, 10th slot top side and 14th slot bottom side the conductor is placed, and same fashion we will place the conductors or coil sides in slot number 11 and slot number 15. The last coil related to the A phase is placed in 15th slot top side and first slot bottom side. Here we have already placed the conductors at the top side of the slot, right. So, in order to place the second coil side, that is at the bottom side, initially we have done the coil side at the top sides, right. So, now if in order to place the coil side at the bottom side, we have to remove the coil side at the top side, then place the coil side at the bottom side, then we have to place the return conductor with respect to the first coil, which is placed in slot 1 and 5. All 6 coils related to the one phase winding is done. We can see under each and every pole 1.5 slot is occupied by first phase, whether it may be A or B or C, depends upon the excitations. So, the A phase winding is done. Next, in order to place the coils related to the next phase, let us consider here we are placing the coils, second slot bottom side at this particular place. So, 2 plus 4 is equals to 6. Already 6th slot is filled with A phase conductors or first phase conductors. So, which is not possible in this combination. So, 2 minus 4 we have to do, that will give minus 2. So, minus 2 plus 18 slots will give 16th slot number. So, this second slot bottom side and 16th slot top side we have to connect, that we will see at the end. Now, we will see whatever the conductors which are going forward manner. We will place the conductors in next slot, that is third slot and 7th slot are filled with one coil, and next 7th slot top side and 11th slot bottom side we will place the conductors, because if we will place the conductors at the bottom side of the third slot, then 3 plus 4 is 7, already one conductor is placed in the 7th slot in a forward direction. In the next conductor should go in a backward manner. Otherwise, the conductors related to the B phase completely placed in third slot and 7th slot, both are coming in forward direction. If we will do in that manner, the winding symmetry will not come with respect to the end ring. For that reason, leave the coils which has to be placed in second slot and third slot bottom side. At the end we will fill these two positions. Now, we will go in forward direction. The coil side which is placed at the top side of the 7th slot is connected to the 11th slot which is placed at the bottom side. Next, 8th slot top side and 12th slot bottom side conductors are connected. Our coil sides we have placed in 8th slot top side and 12th slot bottom side. Next coil we will place in 12th slot top side and 16th slot bottom side. So, similarly the coil related to the next phase we will place in 16th slot top side and 2nd slot bottom side. We can see here initially we have not filled this position, but now 16th slot to 2nd slot bottom we are connecting, and next 17th slot top side to 3rd slot bottom side we are filling the coil or conductors. All 6 coils related to the second phase winding also done. We can see under each and every pole 1.5 slots are accommodated with respect to the second phase. So, the brown color one 3 coil sides placed in under each and every pole. Next we have to place the third winding coil sides, right. We can see here empty places, 3 places are there in under each and every pole. So, the first coil related to the third winding is 4. 4th slot top side and 8th slot bottom side, and next coil 5th slot top side and 9th slot bottom side. If we will consider this part, that is 4th slot bottom side, 4 plus 4 will come 8. So, already 8th slot top side is filled with B phase conductors or second phase conductors. Because of that reason this empty portion or 4th slot bottom side we will place the conductors in a reverse or backward manner, that we will fill at the end of the C phase winding. So, the next coil is placed in 9th slot top side and 13th slot bottom side. We can see the 9th slot top side and 13th slot bottom side one. Next 13th slot top side and 17th slot bottom side. Same way 14 plus 4 will give 18, 14th slot top side and 18th slot bottom side conductors are placed or coil sides are placed related to each and every coil. We can see the coil here, one coil side is placed in 14th slot, next coil side is placed in 18th slot bottom side. So, the last coil related to the third phase or C phase windings are 18th slot top side, that is this portion, and 4th slot bottom side. So, for forward direction with respect to the 4th slot top side will be 8th slot top side, that is not possible, 4th slot bottom to 8th slot top side. That is why we kept empty at the starting. At the end 18th slot top side is connected to the 4th slot bottom side. Like this way the winding coils related to the third phase also placed in the respective slots. We can see the complete coil placements with respect to the all 3 phase windings. Under each and every pole 1.5 slots are accommodated each and every phase. So, the coils related to the A phase winding, we can see here 6 coils are there because the total number of coils are 18. So, 18 by 3 phases will give 6 coils. So, 6 coils related to the A phase I have presented here. So, total 18 coils means 36 terminals we have. So, these 36 terminals we have to connect in such a fashion, then we will get the 3 phase 4 pole winding for symmetrical operation. So, how to connect all these 18 coils with respect to 36 terminals? We have to follow the stubbing approach with arrow representation. Stubbing approach is nothing but virtual representation of these physical coils, and we will follow or we will utilize the arrow representation to connect these 6 coils. Whatever the 6 coils related to each and every phase are there, that 6 coils we will connect by utilizing the arrow representation. So, the number of coils per one stubbed winding we will calculate with respect to the slots per pole per phase, that is 3 by 2. So, one virtual stubbed winding is equivalent of 1.5 windings. So, splitting this winding is not possible, right, once we have placed the coil. So, 3 by 2 number of coils to make one stubbed winding is not possible. Because of that reason we will make the stubbing in different manner, that we will see, and number of stubbed coils to complete the windings also will change. As per the 3 by 2 ratio, for each and every stub winding has 1.5 coil, right. We have to split each coil into half and half. So, which is not possible. So, with respect to that 9 stub windings are required. So, 9 stub windings representation is not possible with respect to the splitting of each winding. So, for that reason we will make the stubbed windings, few stubbed windings with one coil and few stubbed windings with 2 coils. We have 6 coils per phase, right. So, these 6 coils we will represent as 4 sets, like first set will be one coil, second set will be combination of 2 coils, third set also will be one winding and fourth set will be 2 coils, like this manner. So, 2 stub windings consist of 2 coils and 2 stub winding consist of 1 coils respectively, that we can see here. Total number of stub windings required for each and every phase will be 4, and with that number we will get total 12 stubbed winding with respect to 3 phase machine. So, the stubbed winding representation for the first 2 coils, that is placed in first slot and fifth slot and second slot top side and sixth slot bottom side, we can represent in this fashion. It is stub winding 1, that is represented as A1. It is the virtual representation of these 2 coils. Starting will be 1 and ending will be 1 dash. Okay, stubbed winding is nothing but virtual representation of the physical windings. These are the 2 physical windings or 2 physical coils that we are representing with one virtual stubbed winding. And same fashion, second stub winding consists of only one coil, because we cannot split this winding into 2 parts and 1.5 we cannot make it. Because of that reason the complete coil will be one stubbed winding. So, earlier stub winding 1 consists of 2 coils, stub winding 2 consists of only one coil. Okay. Because of one coil in this stubbed winding I represented with dashed line, and same fashion next stub winding consists of 2 coils, that is 10th to 14th one coil, 11th to 15th slots second coil. So, these 2 coils I am representing with one stubbed winding. So, the fourth stubbed winding related to A phase is this one, the coil which is placed in 15th slot and first slot top side. So, A phase has 4 stubbed windings, that 4 stubbed windings we can see here, A1, A2, A3, A4, and with respect to the radial view we can see here first stub winding is representing starting of first coil, that is 1, ending of second coil is 6 dash, and second stub winding starting will be 6, ending will be 10 dash, and third stub winding starting will be 10, ending will be 15 dash, for this one 15 and 1 dash. So, we have to connect these 4 stub windings to complete the A phase winding. And similarly B phase stub winding representation we can see here, this is the virtual representation of first stub winding and second stub winding, third one and fourth. So, B phase also has 4 stubbed windings, each stub winding consists of 1 or 2 coils. So, the first B1 stub winding consists of 1 coil and B2 stub winding consists of 2 coils, those 2 coils are placed in slot number 7 and slot number 11 bottom side, slot number 8 and slot number 12 bottom side. These 2 coils we are joining externally and we are making one stub winding. Earlier also, in order to make the stubbed winding with respect to A1, this connection we have to do externally by utilizing the copper. Same way for A3 also. This is the stub winding with respect to the B3, stub winding with respect to the B4. We can see here the connection for this coil and this coil we have to do manually by utilizing the copper. Same fashion for C phase winding also we can make the stubbing. C1 consists of 2 coils which are stubbed or connected by utilizing the copper wire. Next, second stub winding in C phase consists of only 1 coil. Third stub winding consists of 2 coils. Those 2 coils are placed in slot number 13 and 17 dash, 14 and 18 dash. Then fourth stub winding consists of only 1 coil. We can see here in a fractional slot winding, each the number of stubbed coils are coming 9, but with respect to the 3/2 slots per pole per phase or 3/2 number of coils per one stubbed winding, which is not possible. Because of that reason, so one stubbed winding we have done with 2 coils, other stub winding we have realized with 1 coil. So that cumulatively both stub coils has 3 windings. Okay. Now arrow representation we will discuss with respect to the connections. So the stub winding 1 has arrow in forward direction. For symmetrical and 3 phase greater than 3 phase machines, 1 arrow will be forward and 1 arrow will be backward direction. And for asymmetrical and 2 phase machines, 2 arrows will go forward and 2 arrows will come backward direction. The number of arrows depends upon the number of stubbing coils. Here number of stubbing coils are 12. So 12 arrows will come, 1 arrow will go forward manner, other arrow will come backward manner, because it is a symmetrical 3 phase machine. So the first stub winding arrow direction we can see here, second stub winding arrow will be backward direction, third stub winding arrow will be forward, that is with respect to the C1, fourth stub winding, fifth, 6, 7 like that up to 12th stub winding we can see. Based upon the arrow direction, we will connect the coils to complete the winding diagram. And these are the poles visualization. Under each and every pole 4.5 slots will be there, that is 4.5 slots, and the current with respect to these poles will be in same direction and flux loops also in the same direction. And here north pole, this is south, this is north pole and this is south pole. Now we will make the connections. These are the just virtual representation of the poles. At the end, after making the winding connections by applying the right hand thumb rule, we can visualize the number of poles. Here the arrow representation for stubbed winding 1 is in forward direction, arrow representation for S4 is in backward direction. We can see this is the virtual representation of terminal 1 and terminal 6, the coils which are placed in slot 1 and slot 6 bottom side. Second stub winding consists of only 1 coil which is placed in 6th slot and 10th slot bottom side. Here arrow will be backward, that is S4, here arrow will be forward, that is S1, and here S7. We can see this is the arrow, here it is S10 in backward direction. That will be in this direction. So with respect to these arrows, we will make the connections. First connection we can see here, the starting point will be this one. So arrow S1 is in this direction. So we are coming in this direction and then S1 arrow head is connected to the S4 arrow tail. So, from here to here connection is there. So, that connection is nothing but this one. Here S4 tail point we can see here, arrow point is here. Next S4 arrow starting point or head point of S4 is connected to the tail point of S7. This is tail point is nothing but this one. So, the connection is this thing. We can see the connection. Initially S1 headed to S4 tail, S4 headed to S7 tail, S7 headed to S10 tail. So, this is ending point of A phase, this is starting point of A phase. We have to make the connections in this fashion with respect to the arrows. Arrows I am representing here. This is S7, S4 which are presented here already. For better visualization I am drawing again. This is S10. We can see the connection simply I am connecting one head of the arrow to other tail of the arrow. Okay, here arrow direction is in this fashion. So, this head is connected to the tail point of the next arrow, this head is connected to the tail point of next arrow, that is this connection. At the end this is the final terminal with respect to the A phase. This is starting and this is ending terminal. So, with respect to the arrow representation we can connect the coil in a simplified manner. So, at the end we can see this is the starting point will be first coil which is placed at the top side of slot 1, and the ending will be 15th coil which is placed at the 15th slot top side, this coil, because we are taking the end connection from here, right. So, these two are connected, these two are connected, here these two, this is starting and this is ending A dash. Same way B phase and C phase connections we can see here. B phase is starting from arrow S5, here this arrow is in this direction. So, we are starting from the tail point of S5 and then S5 head is connected to the S8 tail point, that is this one, S8 tail point. Then this connection is done. Then S8 head should be connected to the S11 is this one, S11 tail point. So, these two has to be connected. Then S11 tail head point is this one, that has to be connected to S2 tail point. Arrow is in this direction now. So, with respect to this arrow, head is connected to the next arrow tail and arrow head we are taking out. This is terminal B dash and it is B. Same fashion the 4 arrows related to the C phase we can see here. This is arrow 1 and arrow 2 and arrow 3 and arrow 4. So, with respect to the S3 arrow, where this is the head is connected to the tail of next stubbed winding, and head of the second arrow, that is S6 is this one, head of the S6 is connected to the tail of the S9 and head of the S9 is connected to the tail of the next coil, that is next stub winding S12. So, head related to the 12th coil is coming out, that is C dash. So, these are the final connections related to the A phase, B phase and C phase. So, from these 3 terminals we can give the excitations, the other 3 terminals we can make it either star. If it is delta manner, we have to connect all 6 terminals in delta manner and we can excite the machine with 3 phase supply, and end winding threading and varnishing has to be done after making the winding. Before doing the varnishing and threading, we have to verify the coil placements by utilizing the right hand thumb rule, and current excitation should be 120 degree displaced. Consider any instant let us say A is positive current, B phase having the positive current, C phase having the negative current. So, with respect to this instant, whether 4 poles are forming symmetrically or not, we have to verify. Once the symmetrical poles are forming, then we can do the varnishing and threading etc., and we can bring all 6 terminals out and we can assemble the complete machine. Then we can test at the operating conditions. With this I am concluding this lecture. In this lecture we have discussed the fractional slot winding design and developed winding diagram by utilizing the arrow check approach. Thank you.